Good morning, students. Today we will discuss about orthogonal signals. First, we discuss orthogonality. It is a property that allows transmission of more than one signal over a common channel with successful detection. It means that if we transmit, suppose there are two signals, and these signals are transmitted over a single channel. If they are detected successfully at the receiver end, then it means that these two signals do not interfere with one another and they are independent. So then in that case, these two signals are known as orthogonal signals. Yeah. Orthogonal signals, two signals are said to be orthogonal if they are mutually independent. And if we send or if we transmit two mutually independent or three mutually independent signals over a single channel, then they are successfully detected at the receiver end. If we have two signals and they do not interfere with each other, then both signals are mutually independent and we say that these two signals are orthogonal signals. If we transmit these two signals using one common channel or one channel at the transmitting end and successfully detected the signal at the receiving end, then signals are known as orthogonal. We can understand this orthogonality with the example of vector. First, we discuss orthogonal vector. Suppose these are two vectors A and B. And if in this case, if we want to find the projection of this vector on the vector B, in that case, A cos mod of A cos theta multiplied by B is not equal to 0, or if we rearrange this equation, we get mod of A vector dot product of mod of B cos theta is not equal to 0. Means there is some value of mod of B, there is some value of mod A cos theta. So if we take dot product of vector A and vector B, we get a non-zero quantity here. So we can say that these two vectors are not independent. They are not mutually independent. But if we take a vector like C and B, and if we want to see the project of C vector on B, then this is the projection of C on B is 0. This projection of this vector on this B vector is 0. So if we take dot product of C and B, if we take dot product of vector C and vector B, in that case we get 0. Projection of C vector on B will be 0. Here cos theta or cos 90 is 0, and we get dot product of C and B is 0. In this case, both are independent vectors. They will not interfere with each other. So if we suppose that there are two signals and these two signals are orthogonal, if we take integration and limit is taken from minus infinity to plus infinity, it is for this when x1 and x2 both are non-periodic signals, then the limits are from minus infinity to plus infinity. For non-periodic signal, limit is from minus infinity to plus infinity, and if we take x1 multiplied by x2 dt, if this expression is equal to 0, and this is the condition of orthogonality of two signals. Similarly, the condition for orthogonality of two periodic signals, in this case, this integration and limit is from 0 to t, where t is fundamental period of periodic signals. X1, in this case, x1 and x2 both are periodic signals. So, if integration x1 t x2 t dt is equal to 0, it means that these two periodic signals are orthogonal. So we can say that there is analogy between vector representation and in this integration. This dot product, this is type of inner product, this is integral. Yeah. So for orthogonal signal, inner product or definite integral of two signals should be 0. Then properties of orthogonal signals. First property, two harmonics of different frequencies are always orthogonal. Means these are two harmonics n omega naught t and sine m omega naught t. They have different frequency. Here frequency is n omega naught. In second case, frequency is m omega naught. Means x1 and x2, these are two harmonics, and these two harmonics have different frequencies and also different phases. So because these are orthogonal, if we take, and these are periodic signals. Wait for a minute. Hello. Hello. Two harmonics of different frequencies are always orthogonal. Means x1 is equal to sine n omega t, means different frequency, different phase, different frequency, different phase. These are two harmonics and they have different frequencies and different phase. So if we take integral of these two periodic signals, we get 0 value of integral of sine n omega t plus psi 1 multiplied by sine m omega t plus psi 2, and limit is from 0 to t because sine theta is a periodic signal. Then second property is sine and cosine function with same phase and same frequency are orthogonal. Sine and cosine function with same phase and same frequency are orthogonal. Here sin n omega t plus psi cos n omega t plus psi. Phase is same, frequency is same, and this is sine function, cosine function. So these are always orthogonal. So we get the integration of sine and cos is equal to g, same frequency and same phase. Then third is DC value and sine function are always or also orthogonal. Here sine is periodic function, so we take integration, and limit of integration is from 0 to t. A sine n omega t plus psi is equal to 2. This is the DC value and this is the sine function, and these are orthogonal. Fourth property, if we have two signals x1t and x2t, and if x1t and x2t are orthogonal, it means that integration limit is from 0 to t if x1 and x2 are periodic, and limit is from minus infinity to plus infinity if signals are non-periodic. So in that case, since x1 and x2 are orthogonal, then integration of x1 and x2 is equal to 0. And suppose there is another signal yt, and yt is equal to x1t plus x2t. Since x1t and x2t are orthogonal, then the average power of y of t is equal to sum of average power of x1t and x2t. Similarly, total energy of y of t is equal to sum of total energy of x1 of t and x2 of t. These are the four rules for orthogonal signals. Let us solve some problems on orthogonal signal. Y of t is equal to 2 sine 3 omega t plus 45 plus 4 sine 4 omega naught t plus 35. This is first signal x1t and this is second signal x2t. These are sine function, both are sine functions, and phase is different, frequency is different, so they are orthogonal. If they are orthogonal, it means that if we want to calculate the power of y of t, we simply calculate the power of x1t and x2t, and then we add these two powers. Power of 2 sine 3 omega naught t plus 45. This sinusoidal signal, and for sinusoidal signal, power is given by square of amplitude divided by 2. So here 2 square divided by 2, and in this case whole square of 4 divided by 2, which is equal to 10. Calculate average power and RMS value of signal, where x of t is given by x1t, which is equal to 2 sine 3t, and plus x2t is equal to 3 cos 3 3t plus 5 by 3. In this case, this is sine function, this is cos function, And if sine and cos functions are orthogonal, if they have same frequency and same phase. But in this case, they have same frequency, but their phase their phases are different. Means x1 psi 1 is not equal to psi 2. Modify this signal. In this case, we modify the signal. We know that sine pi by 2 plus theta is cos theta. So if we add here, if we add pi by 2, we get 2 sine 3t plus 3 sine 3t pi by 5 pi by 6. And then we solve this equation by using this. Suppose x1t is a1 sine omega naught t plus psi 1 and x2t is equal to a2 sine omega naught t plus phi 2. Means omega, in this case frequency is same but phase is not same. So in this case, power amplitude is given by amplitude of x1 and x2 is a naught is given by under root a1 square plus a2 square plus 2a1 a2 cos psi 1 minus psi 2. A1 here, a1 is 2, a2 is 3 and psi 1 is 0, psi 2 is 5 pi by 6. So if we put all the values, we get the value of a naught square. 2 square plus 3 square plus 2 multiplied by 3 multiplied by 2 cos, and cos minus theta is cos theta. So yes, and if we substitute the value of cos 5 pi by 6, we get the value of a naught square, and value of a naught square is this. So power is equal to 2.607 divided by 2, and we get the value of power which is 1.303. And RMS value is always under root of power. So we calculate the value of RMS value which is 1.41. Next question. Calculate average power and RMS value of signal x of t. This is the given signal, and you have to calculate the average power and RMS value of this signal. We can easily calculate the average power by using this formula. Integration of mod of x of t, square of mod of x of t dt divided by t. But this question will be solved using orthogonality of signal. So we break this waveform into two waveforms like this. Both are periodic. So we take the limit from 0 to t, and this is x1t and this is x2t. When there is a value of x1t, there is some value of x1t or 6. There is some value of x1t, but in this case, value of x2t is 0, and when value of x1t is 0, there is some value of x2t. So if we multiply x1 and x2, we get 0 plus 0 is equal to 0. Means these two signals are orthogonal signals. So we can easily calculate the power of this 1 by t integration x1 t square of absolute value of x1 t dt, and if we take integration from 0 to t by 2 0 and t by 2, and value of this is 6, so 6 square of 6 dt, and in this case from t by 2 to 6, value of x1 t is 0, and we get the power of px1 is 18 watt. Similarly, in second case, px2 is equal to 1 by t, this, and if we calculate the value of x of t is given by y minus y1 is equal to y2 minus y1 divided by x2 by x1 multiplied by x minus x1. Here, this is the coordinate of x1 and y1, t by 2 and 0, and in this case t and minus 6. X is value of x is t and value of y is minus 6. But when we calculate the power of signal, in that case we take the mod of this, so we can take the mod of when we take the mod of x2 t, this 6 is t, value of x-axis is t and value of y-axis is, we can take the value of y-axis is 6, and if we put these two values in this equation, we get this, and we calculate the power of x2 and x2 t, which is equal to 6. Then yt is equal to 2 sine 3 omega t plus 45 plus 4 sine 4 omega t plus 35. These are two harmonics of different frequencies, so these signals are phase is difference. Both are sinusoidal with frequency is different, phase is different. It means that signals are orthogonal, and we can easily calculate Py is equal to whole square of 2 divided by 2, and so we get that. Similarly, in this case, y of t is equal to 2 plus 4 sine 3 omega t plus 45. Then calculate average power and total energy of signal. Both signals have same frequency, same phase, and this is cosine function, sine function. So these are orthogonal, and when we can easily calculate the power of this signal, which is 2 square by 2, 3 square by 3 square by 2, and we get 6.54 watt. And since this is periodic function, its energy is infinite, so energy is infinite. Then check whether the signals x1 and x2 sketched in the figure are orthogonal. These are two signals. If we take integration, value is from 0 to 1, value of first signal is 1, value of this is 1, from 1 to 2, from 1 to 2, value of this signal is 1, and value of second signal is minus 1, and if we solve, we get 0. So these two signals are orthogonal. Similarly, these are x1 t is equal to sine 2 t, and x2 t is equal to cos 2 t. Determine that these two signals are orthogonal or not. Then we do this x1t multiplied by x2t dt, and we get this. Average value of this is also 0 and average value of this is 0. So we get into 0. It means that these are orthogonal. Then find out that these two signals are orthogonal or not. If we multiply, we get this, and if we simplify this, and we get the value of these two signals are 3 by 2, which is not equal to 0. So these two signals are not equal to 0. I will end this lecture here. Now you will be preparing for your midterm test, Aru. So please give
Hello.
answer of these questions. Hello.
हेलो मैम. हेलो
Yes.
मैम, ये जो ऑर्थोगोनल सिग्नल्स का ये जो पीडीएफ है ना मैम,
Um,
ये शेयर कर देना मैम उस पे
what is
गूगल क्लास.
energy signal, or differentiate between energy and power signal? Hello.